In this video, we're covering what we call equations. So an equation is a statement involving a variable, which we now know is a pronumeral, such as a, b, x, y, numbers, and an equal sign. So an example of an equation could be something such as x plus 2 equals 10. All right. So what it's got is it has our variable, it has some sort of numbers over here, and it includes our equal sign. So I could write another one. We could have 2y over 4 equals 10, for example. Again, it's got some sort of a variable, it's got an equal sign, and we also have a bunch of numbers around here. So the purpose of these is to find out what value fits into that variable, so that what value, what number will satisfy that equation. So if we're looking at x plus 2 equals 10, what number would replace the x to make that true? So when we find the correct value, that makes the equation true. So that's, in a sense, is solving the equation. And that value that we find as the answer is what we call the solution to the equation. So one of the most popular methods, and one of my favorite methods in solving equations, is called the backtracking method. And what this does is this uses, we usually undo operations by performing what we call the inverse operation, which is just the opposite. So on your screen, I'm going to write up our inverse operations. So if I have plus, the inverse of plus is minus. So addition and subtraction. And it goes both ways. So if I had a minus over here, the inverse operation of that is plus. All right. Now, the next one, let's say I had times. That inverse operation is divided by. And again, same way. So if I had divided by, its inverse is times. So the conclusion with this is adding and subtracting are inverse operations, and multiplication and division are inverse operations. So I'm going to go through a few examples here to show you how we solve these kind of equations. So the first one I'm going to write up is x plus 2 equals 20. Now, what I like to do is I like to always have a working line, and that working line is going to show us the inverse operation that we do. So it goes right underneath our equation. So what we're going to look at first is this here, this plus 2. The goal, remember, of these is to get the x by itself. So what do I need to do to get rid of that plus 2? What is its inverse operation, or its opposite? So its opposite is minus 2. But with equations, what you do to one side of the equal sign, so over here we're doing stuff on the left, over here, we also need to do on the right side. So I also need to write minus 2 over here. Now, plus 2 minus 2 cancels out. Hence why they're opposites. I like to say, well, what's left over this side now that we've crossed out that 2? We still have our x, and our equal sign is still there. It's in line. Our new number on the right side, though, is going to be 20 take away 2. So over here, we're going to get 18, because 20 take away 2 is 18. And that's all there is for that example. So I'm going to look at a different example here. This time I'm going to look at subtraction. So what if I had p take away 3 equals 8? Right? Same kind of thing. I want to get the letter, the pronumeral, by itself. So I want to get rid of this 3. So how I do that is, well, what's the opposite of negative 3 or minus 3? Positive. So we're going to plus 3 to both sides. And you guessed it, those will cancel out. What's left over? Our p. Now we have 8 plus 3 is 11, and we've just found that solution. Now if I wanted to say, oh, are you sure this is right? How do you know? Well, what I could do is replace, with substitution, that p with 11. So 11 take away 3 equals 8. That's what we're trying to say. Well, 11 take away 3 is 8, and 8 does in fact equal 8. Therefore, that is true. Now, we'll look at a different example here. This time we're going to look at 3m equals 18. Now, this is a new concept, this 3m. 3m, because mathematicians decided we want to be lazy, is the same as having 3 times m. Okay? So what you could do is you could rewrite it, or you could just go, well, I know that 3m is 3 times m, and the inverse of multiplication is division. So what I could do is go divided by 3. All right? And we can show that as a fraction. So those 3's are going to cancel out. Our m is still up there, so m remains. Then we have 18 over 3, or 18 divided by 3, and then ends up being 6. So we'll do one more. Here we have m over 3 equals 4, and this is the same kind of concept. I don't want this divided by 3 down here, because remember, that's just divided by when it's shown as a fraction. And the inverse of division is multiplication. So what we're going to do is those are going to cancel out, and we're left with our m still, equals 4 times 3, which is 12. Okay, so these are what we know as one-step equations. They're the most simple. You just do one operation, one step to get it to the answer. Work down the page is best. Have your working line, and then show me what it equals underneath. So as you can see, all of these had one working line and then the answer. So quickly, just to recap with our inverse operations, remember they're opposites. So if you have a plus, its inverse is subtraction. If you have a minus or a subtraction, its inverse is addition. Multiplication and division are also inverse operations. So addition, subtraction, multiplication, division. And your whole goal is to get down to some form of a letter equals a number.